Hey aero enthusiasts, and welcome to Aero Briefing. Ever thought about what's holding up thousands of tons of aircraft when it lands or what tucks away neatly after takeoff? It's the landing gear. And today, we're revealing its massive hidden impact on how planes perform, from fuel burn to speed. We'll look at some iconic jets and the engineering marvels beneath them. Fasten your seatbelts. Landing gear is essential on the ground for support, taxiing, and absorbing those landing shocks. But in the air, it's a different story. Early planes had fixed gear, always creating drag. Modern jets need retractable gear to slash that drag and save precious fuel. But here's the catch. This gear is heavy, easily 2.5% to 5% of the plane's maximum takeoff weight. So engineers constantly battle to balance ground utility with in-flight performance. When extended, landing gear is like an open parachute, creating significant aerodynamic drag. Even when stowed, the wheel wells. Those cavities it tucks into add resistance. This drag means engines work harder, burning more fuel, and it reduces the plane's overall efficiency, its lift-to-drag ratio. And the weight? It directly hits fuel burn, how fast the plane can climb, its cruising speed, and how far it can fly. It can even shift the plane's center of gravity, which is vital for stability. You'll see one main design on virtually all commercial jets, the tricycle gear. That's two main sets of wheels under the wings or fuselage and one at the nose. It's stable, gives pilots a great view on the ground, and is super reliable. Older tailwheel designs or specialized tandem gears exist, but for the big jets we're looking at, tricycle is king. Alright, let's see how this plays out in specific aircraft. Airbus A320neo. This narrow-body favorite for shorter routes features a classic tricycle setup, 2 wheels on the nose gear, 2 on each main. Supplied by Safran Landing Systems, its efficient hydraulic retraction is key to minimizing drag, directly boosting fuel economy for those frequent flights. Boeing 737 NG Max. The legendary 737, another narrow-body workhorse, also uses a robust tricycle design. Notably, its NG versions use a titanium main gear beam for weight saving. You might see Alcoa parts on the 737 MAX. Its characteristically shorter gear also makes ground surfacing a bit easier. Boeing 777. Moving to wide bodies, the 777 is built for long haul. Its massive weight needs serious support. So, its main gear bogies each have 6 wheels. This spreads the load. Many 777s also have a steerable rear axle on these main bogies for better airport maneuverability, and titanium is used extensively in its structure. Boeing 787 Dreamliner. This game-changer, known for its composite structure, also innovates below. It uses a 4-wheel bogie system, but the headline is its electrically actuated landing gear, a shift from traditional hydraulics. Safran Landing Systems is behind this advanced, lighter system, complementing the 787's fuel efficiency goals. Airbus. A 330neo, an evolution of a classic, the A330neo's gear, also from Safran Landing Systems, is built tougher to handle increased takeoff weights. It uses advanced materials like high-strength titanium and special HVOF coatings for durability, and features main bogies that tilt neatly backward when retracted. Airbus. A350, Airbus's answer for long-haul efficiency. The A350's gear strategy adapts to its size. The -900 model uses 4-wheel main bogies, while the larger -1000 model steps up to 6-wheel bogies. It's a multi-supplier effort. Safran for the -900 main gear, Liebherr Aerospace for the nose gear, and Collins Aerospace for the -1000 main gear. Extensive use of titanium and corrosion-resistant steels makes it light yet strong. Airbus A380, the Super Jumbo. Its gear is an absolute engineering spectacle with a staggering 22 wheels. 1 2-wheel nose gear, 2 4-wheel bogies under the wings, and 2 6-wheel bogies under the fuselage. This complex system, involving suppliers like Safran, UTC Aerospace Systems, and even Hyundai WIA for components, is essential to distribute its immense weight on standard runways. It even has steerable axles on the fuselage bogies. Interestingly, some of its main wheels are unbraked, a specific design choice for this giant. Across all these aircraft, the landing gear relies on a few key systems: extension and retraction, usually hydraulic. But as we saw with the 787, electric systems are emerging. Critical locking mechanisms ensure the gear stays put. Braking. Powerful multi-disc brakes, typically carbon with anti-skid systems, ABS, are standard. Steering nose-wheel steering is universal, with larger jets adding main gear steering. These systems are incredibly complex and take a beating on every single flight. That's why maintenance is relentless and absolutely vital. The gear's life is measured in landings and years of service. A failure isn't just an inconvenience, it can be catastrophic, so rigorous inspections and component replacements are non-negotiable. So, the landing gear is far more than just wheels. It's a masterpiece of engineering, constantly balancing the demands of ground operations with the need for aerodynamic efficiency and low weight in the air. From the A320neo to the A380, each design is a carefully tuned solution, leveraging advanced materials and complex systems from specialized companies. It's a critical component that allows these amazing machines to safely and efficiently connect our world. What are your thoughts? Did any of these landing gear facts surprise you? Let me know in the comments below and tell us which aircraft's gear impresses you the most. If you enjoyed this deep dive, please smash that like button, subscribe to Aero Briefing for more aviation insights, and hit that notification bell so you don't miss our next flight. Thanks for watching.